Hello everybody, welcome to our next session, and today we are going to discuss a very important concept in 5G which differentiates it from LTE in a very distinct way. And sometimes we hear about 5G only offloading the traffic from LTE or 5G providing more bandwidth, and there are some inherent characteristics in the NR air interface that makes it much better from the LTE side, and this is actually one of them. So let's dig into it and see what's the actual difference. So all of you would have heard about how PDCCH is allocated in the LTE domain. So if we put it into a simplistic diagram, if this is your channel bandwidth and this is your time domain, so all of your control channels, PDCCH, so across your bandwidth, the first 1, 2, or 3, or 4 symbols are actually your PDCCH used for your PS transmission of PDCCH, and this is across the whole bandwidth of a particular carrier. So if you have a 20 megahertz carrier, 10 megahertz carrier, across the entire bandwidth, these PDCCH symbols will be transmitted. So for example, we have high congestion sites, so we have an area where we have a lot of usage of PDCCH. Then you can see that since the PDCCH symbols are being used across the board, across all the bandwidth, there will be a large amount of intercell interference. Now to counter this, I will write LTE here. So now to counter this problem, when the researchers were doing the research on NR, they came up with a concept of CORSET. It's basically the control resource set. So what the idea behind CORSET is that instead of having your PDCCH across the channel bandwidth, you have a certain space within your channel bandwidth where you transmit these PDCCH. So if you look at the NR side, this is your whole channel bandwidth. This is your bandwidth part. We will come to that later. Your CORSET is somewhere here. So this can be 1, 2, 3, or 4 symbols based on whatever, but your CORSETs are not across the board. Your CORSETs there can be multiple CORSETs, and you can place them here, you can place them here, you can place them here. So in this concept, what we can see is that when you have placed, and these CORSETs are actually made up of REGs, which is called a resource element group. Now, you might know from one of my other videos that PDCCH are transmitted in the form of control channel elements. So, 1 CCE is 6 REGs. And based on the aggregation of your PDCCH, you can have 1, 2, 4, 8, and 16 CCEs for that one PDCCH to be transmitted. So within this CORSET, what you can see there's basically your diagram will be like this, that this is your CORSET, this is your REG to CCE mapping, and then you will have multiple PDCCH search spaces. So you can see that based on this concept, your PDCCH search spaces, or where your phone or your UE tries to listen to a PDCCH, is not spread across the bandwidth. What's the advantage? For example, we have you can say an area where we have a lot of PDCCH usage, a lot of control signaling. That could be an area where we have a lot of handovers. There could be an area where we have short calls. That could be an area where we're having a concert, a cricket match, or anything where we have a lot of control signaling happening. And when this control signaling happens across many sites in LTE, then what can happen is we can have a lot of intercell interference on that PDCCH channels, because in LTE they are spread across the bandwidth. So in that case, we can have PDCCH error rate, which can in the end lead to poor performance in the throughput, and also can lead to PDCCH congestion, because PDCCH is a channel which has ACNET. In the NR side, what we can see is that we have spread the PDCCH based on CORSET across the bandwidth, and that gives us the advantage of reducing the intercell interference on your PDCCH, improving the PDCCH error rate, and also improving the PDCCH performance. How it fits into the concept where why we try to use NR instead of LTE is that in highly congested areas, it's better to use NR solution, where NR will give you a better performance on the PDCCH performance. Correspondingly, it will give you a better usage of your spectrum. So goes back to the point where NR has better spectral efficiency than LTE, and this part of the air interface also gives us that better performance in the control signaling part. So I hope you have enjoyed this video, and this is a very interesting concept of CORSET in the NR side. And before I go, I wanted to highlight that this concept is only in the NR standalone, because in the NR non-standalone, the PDCSH information for all the required UEs is sent through the LTE part. So this is another advantage of moving from NR NSA to NR SA, you can say layers, because we will have this advantage. And one, I think, interesting thing which you might do in your networks is that do a simulation run of when you transfer from LTE to NR and see that how much of a gain we have in the PDCCH error rate and correspondingly in the performance. So I hope you liked the video. Please subscribe to the channel. Please share the videos, and let me know of any other topics that you would want to explore. Thank you so much, and see you next time.